This is Geometry Unit 9, Lesson 2 on Trigonometric Ratios. Now, the table that we were looking at yesterday, actually each column of the ratios of the sides, whether it's opposite hypotenuse, and opposite adjacent, all actually have their own name. Those are called the trig ratios. You need to know which ratio is which one and how to find it. So we have, for an acute angle and a right triangle, we have three basic trigonometric ratios that you need to memorize. So the ratio of opposite side to the hypotenuse is called sine. So the sine of an angle is opposite over the hypotenuse. The second ratio is the cosine of the angle, is the adjacent side to the hypotenuse. And the tangent of an angle is the opposite side over the adjacent side. Okay, now remember, when you're doing these, that adjacent and opposite mean opposite whatever angle you have here. So, to help you remember which ratio is which, there's a good mnemonic to use. It's called Sohcahtoa. Sohcahtoa. So some people actually like to write it like this, so it looks more like a ratio. Sohcahtoa. So either way that you do that is correct. Now, when you are doing the ratios, sine, cosine, and tangent, it's important to realize that by themselves, sine, cosine, and tangent have no mathematical meaning. They must include an angle. You can't use opposite and adjacent until you know from what angle you're working from. So, if you have tan of A, you're looking for the tangent of angle A. So you're looking for using the ratio of the sides from a 60 angle A, whatever angle A is. So if it's tan 60, it would mean the tangent of a 60-degree angle. So it's the ratio of the opposite adjacent side when you have a 60-degree angle. But if you just write tan, tan means light brown. So Sohcahtoa helps you remember which ratio is which, and we set up the ratios according to the acute angle that goes with them. Now the trig ratios can be written either as a fraction or a decimal. So let's see if we can figure out the following trig ratios as we go for this one. Now, we have our right triangle here. We have triangle ABC, where BC is 3 and AB is 8. Okay, now first of all, what part of this is the hypotenuse? Well, we know that this is the right angle, so AB will be the hypotenuse. Okay, so opposite and adjacent will depend on which angle you're working from. Now, we don't know AC over here, but since this is a right triangle, how would we find it? Well, I would use Pythagorean Theorem. So to find AC, we would say leg squared plus leg squared equals hypotenuse squared. So that would be A squared plus 3 squared equals 8 squared. So AC squared plus 9 is equal to 64. AC squared is equal to 64 minus 9 is 55. So, and then you want to take the square root of both sides. So AC will equal the square root of 55. And we'll leave it like that for right now, so we're going to be evaluating with this in just a minute. So, now that we know all the sides of the triangle, we can write the ratio based on what information we have. So we need to remember our mnemonic device, first of all. I'm going to write Sohcahtoa up here so we have it. Sohcahtoa. Okay, now when we see sine of A, that is telling me two things. It is telling me use the ratio of the sides for sine based on what angle you're working from. So this says sine of A, so we are going to work from angle A. And remember, sine means opposite over hypotenuse. So this means opposite angle A over the hypotenuse. So what side is opposite angle A? It would be BC. And the hypotenuse is 8. So your sine of A is 3 over 8. The angle A has a ratio of the sides of 3 to 8. So, and if you make that into a decimal, 3 divided by 8 is 0.375. So this is a fraction form, this is in decimal form. Now, the sine of B. So we want to use opposite over hypotenuse, but opposite which angle? Well, we want to start from angle B. Opposite angle B would be here. So that's going to be the square root of 55 over the hypotenuse, which is 8. So when you're dealing with these values, you want to make sure that you just divide them out. So the square root of 55 make sure that you stop your square root. Divided by 8 is about 4 decimal places is good. 0.9270 is your sine. So that's approximately 0.9270. Usually about 4 decimal places is good, but you may be asked to round to a different place, but that's fine. All right, now we're going to do the same thing for cosine. Cosine ratio. Sohcahtoa. Cosine is adjacent over hypotenuse. So again, based on that angle. So adjacent to angle A over the hypotenuse. So we go to angle A. Now remember, the adjacent side is the side it sits on that's not the hypotenuse. So adjacent to angle A would be the square root of 55. It would be this side right here. And the hypotenuse is 8. So it's the square root of 55 over 8. So we already evaluated that one previously for sine of B. So that's going to be minus 0.9270. Okay, next one is the cosine of B. Cosine, again, is adjacent over hypotenuse, but this time we're starting from B. So it's adjacent to angle B over the hypotenuse. So here's angle B. Adjacent to it would be 3, and the hypotenuse is 8. And we did 3/8 up there is 0.375. So that is the ratio from angle B. All right, last two, tangent of A and tangent of B. Tangent is opposite over adjacent. So again, from angle A. Opposite angle A and adjacent to angle A. So the side that is opposite angle A is 3, and adjacent to angle A is the square root of 55. All right, so that's going to be an irrational number, but let's divide it out. 3 divided by the square root of 55. And you get about 0.4045, approximately. 0.4045, and that's your ratio as a fraction and as a decimal. Now, the tangent of B is opposite over adjacent from angle B. So opposite angle B from here is the square root of 55. And adjacent to angle B would be 3. So this is the square root of 55 divided by 3, which is approximately square root of 55. Make sure you stop your square root. Divided by 3 is about 2.4721. 2.4721. So we can find the ratio based on the sides that we have and the angles that we need. So notice that we do not find sine of C, cosine of C, and tangent of C at this level. Those are Algebra 2 and sometimes pre-calculus topics. Sohcahtoa will only work on acute angles. Never, never, never use sine, cosine, or tangent of the right angle at this level. You'll worry about that later on if you take higher math. All right, so let's use the diagram at right to find the following. We are going to find the sine of A. So again, Sohcahtoa. Sohcahtoa. Sine is opposite over hypotenuse based on angle A. So starting from angle A, opposite would be 3. Hypotenuse is 5, because remember the hypotenuse is opposite the right angle. So 3 over 5 is the decimal 0.6. The cosine of A. Cosine is adjacent over hypotenuse starting from angle A. Adjacent would be 4, hypotenuse would be 5. All right, so adjacent over hypotenuse, 4 over 5 is 0.8. And then the last one, tangent of A. Tangent of A is opposite over adjacent. So from A, opposite is 3, adjacent is 4, so that gives me 0.75. So those are my ratio of my sides in this triangle. All right, now, PQR, this triangle over here, R is a right angle, and P and A are congruent. These two angles are congruent, but we don't know any of the sides of the triangle. Can we find the sine of P, the cosine P, and the tangent of P? Well, if this is a right angle and this is a right angle, and these two angles are congruent, what do we know about those two triangles? Well, that means that triangle ABC is similar to triangle PQR by angle-angle. So that means the ratios of the sides are in proportion. So the ratios are the same. So if I was doing the ratio of sine P, sine of P is opposite over hypotenuse. That would be QR is to the hypotenuse, which would be PQ. Okay, now, if I'm looking at these similar triangles, what would be the ratio of QR to PQ? Well, QR is here, that would be BC, and BAB would be the corresponding side there. So isn't BC to AB, isn't that 3 to 5, isn't that opposite over hypotenuse? Yeah, so this is also going to be 0.6. Cosine of P, well, let's see, cosine of P would be adjacent over hypotenuse. Adjacent is PR, hypotenuse is PQ. All right, that would correspond to AC up here and AB down here. So AC over AB, that's adjacent over hypotenuse, which is 4/5, so that's going to be 0.8, and that works for this one. These two are going to have the same ratio. Guess what tan P is going to be? Well, let's see. Tangent would be opposite over hypotenuse, so that, or opposite over adjacent, excuse me, QR over PR. So QR corresponds to BC, and PR corresponds to AC. So isn't that going to be 3/4? Yeah. So that's 0.75. So because these triangles are similar, if you have a congruent angle right here, that right, you can use the same sine, cosine, or tangent ratio for the same angles because the triangles are similar. So the trig ratio values of an angle depend only on the measure of the angle, not on the size of the triangle used. So even though this is a different size triangle, the ratio of the sides will be the same. All angles the same measure will have the same trig ratio. So that's why this table is so useful. So let's look at evaluating trig functions. Exact values of the trig ratios can be found for certain special angles like 0, 30, 45, 60, 90, which will be a future lesson. For most purposes, decimal approximations are good enough. So they don't always come out exact, but you can round them off. Your calculator can find approximations for the trig function ratios for any angle. You know that table that we have on paper? That trig ratio, all those trig ratios are in your calculator. The calculator will do all that work for you. But make sure your calculator is in degree mode. There are two different modes on the graphing calculator. The one we want to have is in degree mode. There's another mode called Radian Mode that's used at Algebra 2 and up level. So you have to know which mode you're in because it's a different measurement and the values will give you a different, when you put in an angle value, it will give you a different measurement. So what you have to do is press the mode key on your calculator and then scroll down. You should have radian and degree should be one of your lines here. If it's on radian, you want to change it to degree. So just arrow over and then press enter. Your calculator has to be in degree mode or you will get a different value. So press second and the mode key to get back to the regular screen and we're ready to go. Okay, so let's do, to evaluate the following to the nearest 10,000ths, which would be 4 decimal places. The sine of 67. What this is saying is find the ratio of sine opposite over hypotenuse when the angle measure is 67 degrees. Now, when we did this on the table, we went to 67 degrees and found the right ratio. So all we have to do on our calculator is grab the calculator and then press sine. Sine, cosine, and tangent are the 3 buttons right here. They're above the comma, then the parentheses. So sine is right here. Sine 67, close your parentheses. Okay, so that looks exactly what's on the paper. Press enter, and we're going to go to about 4 decimal places. So 0.9205 is going to be my value. So I'll flip back here. Sine of 67 is 0.9205. The next one is cosine of 48. Again, cosine is here. 48 goes in parentheses, enter. 0.6691 is your value. 0.6691. And then tangent of 78, do the same thing. Tan 78 is 4.7046.